Good morning everyone. In this class we will be discussing about protocol architecture of GSM with signaling protocols and interfaces. Okay. The following diagram shows the protocol architecture for signaling. Okay. So here if you observe the diagram, we have mainly four parts in the diagram. Okay. The first part is mobile station part, and the second part is BTS part. Third part is BSC, and the fourth is MSC. Okay, and all these parts of this protocol architecture for signaling are joined with an interface. Okay, the first and second part, that is MS and BTS part, is joined via an interface UM. Second part and third part, BTS part and BSC part, lies in the interface A bias. Third part and fourth part, that is BSC and MSC, lies in the interface A. Okay, this is the protocol architecture for signaling. Okay. As we already discussed about the UM interface, which is called as radio interface, here also the main interest lies in UM interface only, and remaining other interfaces occur between few entities which are in the fixed network. Okay, this UM interface lies in the physical layer, that is layer 1 in OSI model, and this physical layer plays a major role in this protocol architecture for signaling. So what are the operations which physical layer does is it handles all radio specific functions. Okay, there are few radio specific functions, like mainly five radio functions will be there. Those are creation of burst, multiplexing of burst into TDMA frame, synchronization with BTS, detection of idle channels, measurement of channel quality on downlink, and it also uses GMSK. These are the main things which physical layer performs. Okay. So here creation of burst is done in five different parts. Okay. Normally in last class we have discussed about radio interface. There we have seen normal burst. Means each and every TDMA frame is divided into normal burst, and this division of burst is done according to five different formats. The first one is multiplexing of burst into TDMA frame. Means multiplexing means joining all different signals and forming a burst which gives the TDMA frame. Okay, here the first part of creation of burst is multiplexing of burst into TDMA frame, which joins all the different signals at one place to create a burst and to form it as a TDMA frame. Then second one is synchronization with BTS. Synchronization also includes the correction of individual path delay between MS and BTS. If there is any data delay, then synchronization is the thing which synchronizes the individual path delay between mobile station and BTS. Okay. Single BTS will manage one or more MSs. Okay, in the GSM architecture, we have seen one or more MSs can be connected to BTS. Whatever the mobile stations are connected to the BTS, those mobile stations are handled by that particular BTS only. Okay, and here the problematic aspect is round trip times, RTT, round trip times. Here what happens means Some mobile stations are very close to BTS. Some mobile stations are little bit far away from BTS. At that time what happens when data is transferred? That time the mobile station which is closer to BTS will be transferred first, and the mobile station which is far away from BTS will be transferred little bit late. In the radio interface diagram, we have seen for every slot there is a guard space. First and last, we have left some space is left for guard space to manage this only. If MS is far away, then without correction, large spaces would be required because data has to be transferred from some 35 kilometers or 45 kilometers. That time, large number of guard spaces would be required. Means their space is getting wasted. Okay, this is the problem C. So here what happens, BTS sends the current RTT round trip times to avoid this problematic situation, to avoid this occupying large guard spaces. What BTS will do is, BTS will send current round trip time to the mobile station. So round trip time means this mobile station is this much far away, and data which is transferred maybe takes this much amount of time. Like that, it will send some RTT to MS, round trip time rate to MS. So that time BTS will adjust its access time so that all the normal burst, all the data will reach BTS within their limits. So to avoid this situation only, BTS will send the current RTT to MS. This mechanism reduces guard spaces. That is the advantage. So synchronization between mobile station and also BTS is very important here. The next one is detection of idle channels. Detection of idle channels means in GSM 900 we have totally 124 channels. If at all any mobile station in the TDMA frame is not transferring any data, that time that channel space is wasted. Okay, out of 124 channels, one channel space is wasted because mobile station is not sending any data. So that time it will detect the idle channels and it will use that particular idle channel for remaining mobile station in order to avoid wastage of channel movement and time. This is about detection of idle channels. And second and next one is measurement of channel quality on downlink. Channel quality, how data is transmitting, is it transferring within the time or not, how the data is lost in the middle, like that. It will check the channel quality on downlink. These are the 5 steps included in the creation of burst. In this creation of burst is handled by physical layer. Okay. Apart from this, it also uses the GMSK method. GMSK method is nothing but Gaussian minimum shift keying. This Gaussian minimum shift keying is used for digital modulation. Digital modulation means it performs encryption and decryption of data. Okay, and encryption is not performed completely end to end here. Okay, this encryption is performed only between MS and BSS. MS and BSS over the air interface only, not directly, not completely end to end, not completely from source to the destination, but encryption here is performed only between MS and BSS. Okay, this is the use of GMS. Okay. All these are performed by physical layer. Not only this, there are few by physical layer. They are channel coding. The first one is channel coding. These 4 are considered as main tasks of physical layer. Channel coding. So here coding mechanisms are performed. This coding makes extensive use of forward error correction. We have seen this forward error correction method in bearer services. Okay. So here this channel coding will use forward error correction, which is used for redundancy and allowing detection and correction of selected errors. Okay, this FEC, forward error correction, is used for redundancy and allowing for detection and correction of selected errors. So channel coding uses this forward error correction. This forward error correction is one of the reason why error detection and correction occurs in only layer 1 but not in layer 2 in ISA model. Because physical layer is the main layer in ISA model, all these error detection and correction mechanisms are performed in only layer 1 but not in the remaining layers of the ISO reference model. Okay, GSM physical layer always tries to correct error, but it will not deliver erroneous data to higher level. Means it will not give any problematic situations to the remaining layers. It always tries to correct the problems occurred in the physical layer itself. Okay, that is the main thing performed in channel coding. And the next one is error detection and error correction. This error detection and error correction is performed by the technique forward error correction only. Okay, this is already discussed in bearer services. Okay, in non-transparent bearer services. And third one is VAD, voice activity detection. Okay, in GSM, voice is assumed as the main service. Physical layer also contains some special functions which uses voice activity detection. Here what happens means voice data is transferred only when the voice signal is present. That is the main thing in this voice activity detection. Why this mechanism is used means it helps to decrease interference as the channel might be silent sometime. Channel might be silent sometime means whenever two speakers are there, whenever mm, two mobile stations are contacting each other, that time one person may be talking and one person may be listening. So the other person will stay silent until the first person stops talking. Means we don't know whether the first person now stops talking at this time or at that time. So we will wait for the first person till he stops talking. So here that little space is getting wasted. For us it may be like little space, but there it is some milliseconds, microseconds like that. So wastage of milliseconds and microseconds may lead to the decreasement of GSM channels. So that is the reason that wastage has to be not occurred, so that voice activity detection is used. Okay, so this is one of the thing in voice activity detection. There is also one more thing called comfort noise. See, when two speakers are talking to each other, that time what happens, if both are silent for some time, for some milliseconds, that time no voice is transmitted in between two speakers. So the two speakers may get confused that whether the call has cut or some disturbance, some problem has occurred or what, they don't understand, because that time is completely silent. So to avoid that situation, uh, uh, to avoid or to make user comfortably, they will generate a comfort noise so that it will uh, create some comfort noise so that both the speakers will understand that there is no disturbance and there is no call cut in the middle. So that comfort noise generates some noise which avoids the confusion in between two users. Okay, this is about comfort noise. Okay. So in the architecture we have some names, like if you observe CM, MM, RR, LAPD, uh, RR, BTSM, BSS, MAP, like that. We will discuss one by one. First we will discuss about LAPD. Okay. LAPD means Link Access Protocol for D channel. Okay. This protocol is defined at the UM interface. Okay. It lies over the UM interface in the physical layer. So the name itself implies that it is a link access procedure for D channel. Okay, it is a version of HDLC which is developed in 1997. LAPD is called as lightweight LAPD. Why it is called lightweight LAPD means it does not need any synchronization flags or checksumming for error detection. Means it will not perform any synchronization of flags or it will not perform any checksumming for error detection, because all these things are performed by physical layer itself. So that is why, as there is no extra or as there is no extra burden over LAPD, it is called as lightweight LAPD. But LAPD offers reliable data transfer. Okay. Second point is it offers reliable data transfers. So over all the correct connections it offers reliable data transfers, and also it gives resequencing of data frames. Okay, means whenever data is transferred, so that same frame again come back after 477 microseconds, means again that same frame is used for some other mobile station to transfer the data of that particular mobile station. So this is nothing but resequencing of data frames after the usage. This is done by LAPD. And the second one is flow control. If it all data flow is very fast, that time also by using guard space it is controlled by LAPD. If data flow is having delay, that time also it will arrange some guard spaces and it will control the data flow. This is also done by LAPD. And the third one is segmentation. LAPD includes segmentation, means it will form all the signals, all the protocols in a single format, and then it will transfer the data. Different signals, different interfaces are kept together and data is transferred without any delay, without any problem, is called segmentation. That is also performed by LAPD. And the next one is reassembly of data. Reassembly of data means data is when mobile station is when mobile station has started transferring data. At that time, data is kept like the same format which is delivered by mobile station. It reassembles all the data and then it transfers the data. And the last one is acknowledged or unacknowledged data transfer. Sometimes, in some cases, from some point to other point, data is acknowledged. From some point to other point, data is no need to be acknowledged. So this acknowledged and unacknowledged data transfer is also performed by LAPD. whenever we send any message, that time soon after delivery of the message, we will be getting a message like your message has been delivered to the other person. That is an acknowledged data, means we are getting that acknowledgement. But in the middle, like some BTS to BSS or BSS to MSC, like that, there no need to be acknowledgement. There no need of any acknowledgement, because without any packet loss they will send the data to destination. So that time there is no need of acknowledgements. Both these acknowledged and unacknowledged data transfers are performed by LAPD. And the second one is RR. If you see in the diagram, the middle part is RR. In the first protocol architecture diagram, the middle part is RR. Okay, what are the functionalities of RR means? All setting a connections between MS, BSS, MS, BTS, BTS to BSS, BSS to MSC. All these connections are done by radio resource management only. RR means radio resource management. Only part of this layer is situated here, but remaining part is situated at the BSC only. Only few part of the layer here is implemented in the BTS. Remaining part is situated at the BSC. Here the main task of RR is first setting a connection and maintaining the connection. After setting up a connection between two things, it will maintain the connection until data is transferred without any packet loss. And the third one is release of radio channels. Means it releases all information and offers a reliable connection to the next higher layers. You can also access the physical layer directly, which gives you the information and also offers reliable connection to all remaining layers. These are the functionalities of radio resource management. Okay, remaining things we will discuss in the next class. If you are having any doubts, please feel free to contact me. Thank you.